This is the second part of your online module describing probabilities. Now we are focusing on continuous distributions, and we have two different distributions that we're going to focus on. First of all, let's refresh what a percentile is. This is fully contained in your normal distribution online module, but let's call to the fact that a percentile is basically the percentage of observations that fall below a given specific point. So graphically, for example, here, if we have a normal distribution that centers in 1500, and we set the target value to be 1800, then we will calculate what's the percentage of observations that fall below that specific observation of 1800. So that's how we interpret these types of curves. Usually, the usually approach to read these percentiles are from left to right, which means like all the probabilities that you encounter will be cumulative till that point. Then for some other characterizations, we will need to do other calculations and extensions of the analysis, which are covered in your normal distribution online module. But this is the general definition of a percentile. So in the space of the continuous distributions, there are two distributions that are really important for you to be familiarized with. The first one is the chi-square distribution. The chi-square distribution only has one parameter of interest, which is called V. Depends on the number of observations. And the nature of a chi-square distribution is basically it's generated by putting together a bunch of standard normal distributions. So if they are all summed up together, then they build a chi-square distribution. So this is how it looks. As you see, there is some skewness, so it is skewed to the right, but this is a distribution by itself, right? So for example, it will be important for you to say, okay, so will I treat this maybe as a skewed normal, or is this really a chi-square distribution, right? So whenever you are running a couple of tests that we're going to be talking about later in the inference section, you're going to focus into this one specifically whenever necessary. So how do we calculate these distributions and these probabilities at some points? So let's say that, for example, you're interested on calculating the probability all the way from the beginning of the distribution till the value 15. So as you can see, this distribution is actually located around 7. The degrees of freedom of the distribution is actually 7. I calculated it myself. So the probability for this chi-square distribution is calculated through the following commands in R. So you give the threshold value, then you give the degrees of freedom that the distribution has, and then you indicate which tail would you like to count. So for this case, I'm saying lower tail true. So it counts all the probability that accumulates from the beginning till that point. On the other hand, if you're interested in getting the other part of the tail, right, so you would say lower tail false, so you will take the upper side of that distribution. So as you can see, if you do that, then you will get the complement for that is remaining to get to 1, which is the full probability of the whole distribution, right? So you can also go backwards. For example, say, okay, so what is the point that will give me 95% of the probability? As you can see before, at 15, we already have 96. So you sure know that in order to get 95% of the probability, then it should be a value below 15. For getting that, then we use Q chi-square, which is for cumulative. And then we use 0.95, which is the target probability that we want to check, the degrees of freedom, tell it about the lower tail being true, and then it will give us the actual value for which we're going to get 95% of the probability, which is just below 15. Okay. And the last one that we have is the F distribution. This distribution is basically built from having two independent variables that follow a chi-square distribution, and each of one have degrees of freedom, so we will call it V1 and V2. So this is the shape of an F distribution. So as you can see, it's even more pronounced than the chi-square. So it has a higher concentration at the very beginning and then a long tail. So as you could expect, like the majority of the probability like concentrates at the very beginning. Therefore, let's see how do we calculate things here. So here, for example, we can check, okay, if I am interested in checking what's the probability of the cumulative probability for getting up to the value of 4. Then you give the target value, you give the first degree of freedom, the second degree of freedom. This is an F distribution with V1 equals 2, V1 equals 5, V2 equals 2. And we find that this will be the probability that it's contained over this amount. And from there, of course, we can do what we did with the chi-square, right? So let's say that we want to actually identify where is it that the 95 percentile will fall for this type of distribution with V1 equals 5 and V2 equals 2. So you give those parameters to QF, and then it will tell you that the value of 19.29, which will be located really far along the distribution, is where your critical value will be located for this type of distribution accumulation. Okay, so those are the two that you need to be familiarized with. When we jump to inference, the chi-square distribution will be used for a couple of areas, and then the F distribution is used for a lot more, especially in regression, ANOVA, and many others. So this is your time to practice. This is a reminder of the learning objectives. Please take the quiz for checking your understanding.